Welcome back, programmers! In this video I will make you the master of puppets of PureBasic. How am I going to do that? Well, by showing you compiler directives. They are a set of commands that target the compiler and tell it exactly how to build your files, how to behave depending on the conditions. It's very practical when it comes to, for example, building portable code. You want to have one single code that can compile on Linux, Windows, Mac OS, you can use those. You want to have one single code that can compile with different versions of the compiler, also compiler directives. And more than that, you can really control the way the compiler is behaving, and it is very powerful. Also, we have reached more than 200 subscribers, almost 240 at this time, so thanks to all of you. As promised, I will give away a Pure Programming t-shirt. You want to win a t-shirt? Easy, go to this video, drop a comment in the comment section, and in the next video I will pick someone at random and give away the t-shirt. And finally, recently I have created a PureBasic cheat sheet. It's a single-page document with all the PureBasic syntax and keywords at once on one page. Very useful. You can download this document on my website. The link is in the description box. So, compiler directives, let's go. Okay, so compiler directives. First, what are they? Well, just as their name says, they are commands aimed to control the compiler, the way your code is compiled. Okay, you have the compile time. The PureBasic compiler takes your source code, turns it into an assembly code, and then turns it into an executable file. And then when you run the file, this is the runtime, when all the commands within your executable are run. Here we're talking about compiler directives, so commands that let you control the way the compiler is working on your file. So one quick that you already know is the enable explicit and the disable explicit. So it tells the compiler that all variables must be defined explicitly, and the disable explicit turn this explicit definition off. I recommend that you use enable explicit all the time. You put that at the top of your file or the top of your module and you're good to go. One exception is maybe when you want to work with old code or someone gives you a large piece of code that is not using the enable explicit, you can surround this code by disable explicit and enable explicit at the end, and between these two compiler directives, you won't need any declaration, so you can work it step by step to replace all your code, or even if you don't want to touch this code because you know it works and you don't want to mess with it, just surround it with disable explicit, enable explicit, and you will be okay. But I recommend, if you are writing new code, always use enable explicit. That's two first compiler directives. Then you have the easy compiler warning, compiler error. They're just displaying warning message and an error message, just like, but on the compiling section, meaning it's a compiler warning, compile warning, and compile error. Okay, just like if you were doing a syntax error in your code, but here it's you that's telling the computer, that's telling the compiler to display a compiling error or compiler warning. So let's have a look quickly at that. So for the warning, here it will display this is a warning whenever you build it, and for the error it will display, boom, it's an error, line 2, this is an error, and it will display whatever you tell him, and the line is of course the line where this compile error is called. is not very useful, right? Just like this, but you'll see it can get very interesting right here. So let's start. Compiler if, compiler select. So first, compiler if, it works exactly as the if block, okay? If, else, and if. You can look at this video, and it works the same, except that here the expression that is evaluated must be a constant expression. Of course, we are talking about compile time, so the compiler cannot use, of course, variables, because it doesn't know the value of the variables yet. So you have to use constant expression, but in your constant expression you can use any operator, okay? Addition, subtraction, multiplication, division, whatever, greater than, less than, okay? Everything except, and that might be a bug, except for the XOR, the logical XOR. You cannot use that. But you could use, let's say, PB compiler version less than 472, or compiler version, I don't know, something else. So what does it do exactly? Well, just like an if, it's a conditional block, and basically it will tell the compiler to go through this code, or this code, or this code. Okay? So here, if I run this, if the compiler version is before the 4.72, I will display hello. If it's before the 5.70, I will display hola. Otherwise, I will display OK. If I run this, I have the 5.72, it displays OK. But here, if I put a 6, it will display hola because it only executes this. So it tells the compiler which code to compile. So here, only this line is compiled. In the executable at the end, if you look at really the assembly code or even the binary code, if you can read binary code, you'll see that there is no code for this or for that, because it's at compile time that the compiler will only compile whatever fits, whatever matches the condition here. Okay, so that's how you use the compiler if. It's very useful for compiler version. It can be useful as well for choosing different code depending on the OS you're running on. And we'll see that with the next example. So compiler if, compiler else if, compiler else, compiler and if. And we also have the compiler select with the compiler case, compiler default, and the compiler and select. It works the same as the select in the code, except that once again the expression must be a constant expression, and also the compiler cases must be constant values. And last thing, you cannot use multiple cases with commas, and you cannot use value ranges with the two keywords. Only one single constant value in the compiler cases. And that's it. So one quick example that is used a lot is here PB compiler OS, okay, and you have compiler case for PB OS, let's say Linux. You're gonna have one compiler case for, okay, you can have something like that, PBOS Windows, PBOS Mac OS, and compiler default. So here you can put whatever code is specific to Linux, here to Windows, and here whatever code is specific to Mac OS. And for example, here you could say compiler error OS not supported. If you're not on one of the three OSs, it will generate, it will raise a compile error. So compiler select works exactly the same as the select. We're very close to the compiler if, except that you can have several cases like this. So all this works with, as I said, constant expression, okay, in the compiler is, if, or else if, in the compiler select or compiler case. So what are you going to use for your constants? Well, PureBasic defines a lot of constants that you can use and that the compiler can change for every line of code it is compiling. So you can use the PB compiler OS, as we saw, with these 3 values. You can use the PB compiler processor with these 2 values. You can use the executable format, okay? And you can use all these. Look at that. Compiler date, what is the current date at compile time? What is the current file? The file path, the file name, what is the current line being compiled, what is the current procedure name, current module name, okay, compiler version, okay, all this, even compiler home, where is your PureBasic compiler, installed, is it running the debugger, PB compiler debugger, so you can have some specific code based on if you're running the compiler or not. Is it thread safe? Is it using Unicode? Is it using the enable ASM? Is it using the enable explicit? So is the enable explicit enabled or is it disabled? Are we running the main file? Are we compiling an include file? So remember in the video about modules, I was using this PB compiler is main file to run the example, the main code, if you run the module as an example. That's a lot of constants, so you can use all this. You can use, of course, hard-coded values like I did with my 5.72 or 572, etc. Then you have more. You have compiler constant that you can find in the compiler options. If I open the compiler options here, you can see here in constants, you have editor constant and you have also custom constants. So let me switch to the other one. Constants, you can enable the PB editor compile count that will return the number of times your file has been compiled. The build counts the number of times your project has been built. The editor create executable is is the compiler creating an executable file or is it just running like with SF5? And you can also define custom constant, whatever you want. You just type hashtag or # your constant name equals the value, and in a value, as a value, you can use environment variables, okay, Windows or Linux or macOS environment variables with this $sign in front, okay? So here the creator will be my username, the username with which I'm logged in my Windows session. So let's have a look at these, for example. So here, I have this quick, okay, PB editor compile count. I'm just debugging, so I'm just displaying that. And in a compiler, if PB editor create executable, I display a message requester. So if I run it with F5, it's not going to create an executable. So the PB editor create executable is going to be false. So I'm not going to run the message requester. F5. See, my compile count is 11, my build count is 2, and I don't see any message requester. To see the message requester, I need to create an executable. So create executable, r.exe. Now, in the executable, the compiler has compiled this message requester. So if we run it, you see we have the creating executable message requester, because at the time of the compilation we were creating an executable, so this constant was true. And I can use also, I can debug, I think it was YouTube rocks, okay, and I can debug also creator, I think. Let's run this. YouTube Rocks is 1 and Creator is pure programming. So that works. You can also use custom constants. And yes, I did not say it, but here you have checkboxes. If you remove one checkbox, let's say you don't want to use compile count, sorry. If I run it, the compiler will raise an error because the PB editor compile count is not defined. I cannot use it like this. And we see later we can fix that. Let's put it back. Okay. Also, that all this works for all OSs, but you have one special Windows only information. It's about the version info. Once again, in the compiler options, you have this tab, version info, and you can put some version information here in these fields. Okay. In these fields, you can use the following tokens: %OS for the OS being used, %source, etc. You can use even dates information to build up your different fields here. And those fields, all those fields here are available as constants in your program. Okay, so let's say here the company name is pure programming. I can use PB editor company name. So if I go back here and I want to debug PB editor company name, you see pure programming, it works. I have access to the company name. So this works only on Windows. So that's a lot of different constants that you can use when you are using compiler directives. So two more that are not defined as compiler directives in the documentation. Actually, they are defined as compiler functions. But, okay, I mean, it's not very different, it's very thin. So here, when you're using compiler if or compiler select, the defined here, define function, compiler function, is very useful if you want to check that an object, an entity, has been defined already. An entity could be anything, okay, one of those you can check for. Constant, variables, arrays, lists, maps, structure, etc. The list is here. You can check for any entity. Is my procedure already defined? And I can put some conditional compiling code depending if a procedure has already been defined or not, if a label has been defined or not, etc., etc. And for example, if I go back here, as I said, remember, I can do that, PB editor compile count. So I'm checking, so the first parameter here must be undecorated, okay, meaning you don't have to put the pound sign or the hashtag. You don't have to put the star when you were talking about pointers. No parentheses for arrays, list of map, etc. So just the name, the plain name of the entity you want to check. So here, PB editor, is it defined? If it's defined, I can debug it. I could even put a compiler else here saying anything, or I just even compiler error not defined. So if I run this, here it's defined, but if I go back to my compiler options in my constant and I don't enable the compile count, I've got an error because it's not defined. And if I don't put this code here, the code works fine even if my PB editor compile count constant is not defined. And so, as I said, you can check for any entity. Okay, the list is here. So it's very, very useful working with in conjunction with the compiler if or compiler select. Very useful. And finally, well, not finally, compiler if subsystem. So the subsystem function, compiler function, returns if the specific subsystem is used for your program. So you have only 3 subsystems, okay? OpenGL tells it's on Windows only, tells you if the OpenGL subsystem has been used instead of the DirectX. And for Linux, you have GTK2 or Qt. And the check is actually case insensitive, okay? You can call subsystem OpenGL with the weird case here like that. This will work. We can try this in the test file. F5. OpenGL is not used. I don't debug anything, but we'll talk about subsystem maybe in a later video. But here, if I put OpenGL and I run it, this will debug OpenGL because the OpenGL subsystem is defined. And finally, enable ASM, disable ASM. These are just 2 keywords, 2 directives to tell that you want to enable inline assembler, inline assembly code. So it's very advanced if you want to write directly assembly code, or if you have already some procedure or some pieces of code that are written in assembly code and you want to put them in your code. Maybe you think that writing, and that's true, writing assembly code can be much faster than having some code compiled because it's really optimized to what you need. You can surround that with enable ASM, disable ASM, and you write your assembly code between those 2. And that will do the trick. That will tell the compiler then the assembler keywords can be used directly in the source code. Okay, so very advanced. I will not be too long on that topic. And that's it for the compiler directives. And voila, you are now the master of puppets of PureBasic. The compiler does what you wish. As usual, don't forget to like the video. If you enjoyed it, you can subscribe right here, check out my social media right there, and check out the latest videos right here. You can still buy you a nice t-shirt like this one on my merchandising website. Check it out in the description. That being said, thank you all for watching. I will see you soon.